In this class, we'll see the system realization with cascade format. Okay, suppose if the system is there whose transfer function is h of s, then x of s is input, y of s is the output. Again, suppose if there are three systems with the transfer function h1s, h2s, h3s, and all these three smaller systems are connected in cascade, so that we can, the overall response h of s is just the multiplication of individual transfer function. Okay, h of s is equal to h1, h2, and h3. Then for the first system, x1 of s is the input, y1 of is output, and for second system, x2 of s is input, y2 of s is output. For the third system, x3 of s is input, y3 of s is output. Okay, then, but see the again this x of s is the overall input, okay, main input, and y of s is the overall output. But x of s is same as x1 of s, y1 of s is same as x2 of s, y2 of s is same as x3 of s, and y3 of s is same as y of s. The overall transfer function h of s is equal to h1s, h2, and h3. Then we know what is h1. Okay, the output divided by input, that is y1s divided by x1s. And for the second system, y2 divided by x2. For the third system, y3 divided by x3. And we know that y1 is same as x2 because y1 is same as x2. Okay, so this will cancel each other. And also y2 is same as x3, so this also will cancel. So what is remaining? Y3 divided by x1, and we know that y3 is y, x1 is x. So again we are getting overall transfer function. So in general we will be given with h of s. So from h of s, okay, from h of s, okay, we have to modify that h of s so that we are getting h1 of s, h2 of s, and h3 of s separately. Okay, from the h of s, we have to modify that equations, okay, transfer function in such a way we are getting h1 of s, h2 of s, and h3 of s. Now we will be separately implementing, okay, h1 of s will be separately implementing with some structure, okay, either with the direct form 1 or direct form 2. And similarly for h of 2 also will be representing separately, h3 we will be representing separately. Then finally we will connect all the things, then we'll get the cascade form of connection. It is just like the overall system that we are breaking down into the smaller system, then we are realizing in the simpler format, then later we are just connecting it. Okay, so this is the cascade connection format. Now we'll try to solve one problem based on this. Realize the given h of s in cascade form. H of s is equal to, again, the numerator will try to find out the factor 4 into s plus 1 into s plus 3. In the denominator, there will be three terms, that is s plus 0.5, s plus 2, s plus 4. Okay, now we can divide this into three parts, that is 4 by s plus 0.5, then s plus 1 divided by s plus 2, then s plus 3 divided by s plus 4. Okay, we can write like this. And this is something similar to h of s is equal to h1 of s, h2 of s, then h3 of s. Now we know h1 and h2 and h3 separately. Okay, now we have to separately realize it using direct form 2. Then later we will connect together everything. Okay, then what is h1 of s? That is 4 divided by s plus 0.5. Okay, so h1s is equal to 4 divided by s plus 0.5. That is equal to 4. If you take s outside, this is 1 plus 0.5 divided by s. Thus, s we can take in the numerator, that is 4 by s divided by 1 plus 0.5 divided by s. Okay, now we will implement this h1 of s with the direct form 2. Okay, once if it is direct form 2, we will be using y1 of s divided by wn(s), and then w1s divided by x1s. Because in general, h1s means y1s divided by x1s, but for realization with the direct form 2, we are introducing this w1s. Okay, so now from this, what is y1s divided by wn(s), that is 4 by s, then w1s divided by x1s is equal to 1 divided by 1 plus 0.5 divided by s. Okay, now From this, what we need so y1 of s, again w1 is the intermediate variable, that is 4 by s w1 s. Okay, again cross multiply this, be getting w1 s is equal to w1 s plus 0.5 by s w1 s is equal to x1 s. Okay, but here we need W1S with respect to X1S and W1S. So we'll just modify this. Okay, W1S is equal to X1S minus zero point 0.5 divided by S W1S. Okay, now we have equation for Y1, that is output side, and also equation with respect to input side. Okay, now I will draw it here. Say x1 is input. Okay, input, and it's going like this. Okay, then we use one integrator here, 1 by s. Again, for a integrator, again here this is w1s. Okay, w1 is multiplied with 1 by s, again with a coefficient of minus 0.5. Okay, now we can add this here. Okay, now this part is over. Okay, see, we need w1 of s. w1 of s is equal to x1 of s plus w1 of s multiplied with 1 by s into minus 0.5. So now we got this structure. So from this we have to get y1 of s. y1 of s is simply 4 by s into w1 s. 4 by s into w1 s. Already w1 s is there, and also 1 by s is there. So from here you take the tapping, then you just multiply with the 4. Okay, then you will be getting y1 of s. Okay, so now we have realized the h1 of s. Okay, this is the realization of h1 of s. Okay, now we have realized the h1 of s, but that too with the direct form 2 format. Okay, similarly we have to realize h2 of s and also h3 of s. Okay, so h2 of s is equal to s plus 1 divided by s plus 2. This we can write like 1 plus 1 by s divided by 1 plus 2 by s, again y2 s divided by w2 s w2 s divided by x2 s. Okay, so now from this we can take w2 s divided by x2 s is same as 1 by 1 plus 2 by s. That means denominator we are taking. Okay, for the output we will be taking numerator. Then y2s divided by w2s is equal to 1 plus 1 by s. Okay, now we can cross multiply this. w2s 1 by s w2s is equal to x2s. Here if you cross multiply, y2s is equal to w2s 1 by s w2s. Okay, now we need W2S with respect to X2S. So W2S is equal to X2S minus 1 by S W2S. Okay, already this is of in the same format. Okay, in the correct format. So because we need Y2, that is function of W2. Okay, that we can easily draw here. Okay, now you take X2 of S. Okay, X2 of S. Okay, we need to form the variable, that is w2s. Okay, where x2 of s is added first, then w2s is multiplied with 1 by s. Come this way, multiply with 1 by s, then with a gain of I think somewhere we are making a mistake. W2, yes, W2, this is 2 by s. If it is 2 by s, this is minus 2 by s. Okay, so with a gain of minus 2, with a gain of minus 2, then connect here. Okay, with a gain of minus 2, then what is there at the output side? Y2 of s is w2s as well as 1 by s multiplied with w2s. Okay, so anyway, W to S we can get directly here, and also W to S multiplied with 1 by S. W2 multiplied with 1 by S. Here gain is 1 only, so I will put 1. Then we can get Y2 of S. Okay, so in the similar manner, we have to realize H of 3S also, H3S. H3S. H3S is equal to S plus 3 divided by S plus 4. Then we can write like 1 plus 3 by S, 1 plus 4 by S. And this is Y3S divided by W3S. W3S divided by X3S. Okay, now W3S, W3 divided by X3 is equal to 1 by 1 plus 4 by S. So similarly, Y3 divided by W3 is equal to 1 plus 3 by S. Okay, now cross multiply this. W3 W3S plus 4 by S W3S is equal to X3S, but we need W3S. W3S is equal to X3S minus 4 by S W3S. Okay, again you cross multiply this, we'll be getting Y3S is equal to W3S plus 3 by S W3S. Okay, now from these two equations we have to realize. Okay, so X3 of S is the input. Directly we take that input. Again we need to get W. We need to get W3 of S. Okay, that means W3 of S we need. X3 of S is already there. Then you multiply with one integrator, that is 1 by S, and also with the coefficient minus 4. Okay, minus 4, and it goes like this. Then we need Y3 of S. For that we need W3 of S directly. Okay, directly we are taking W3 of S, and also W3 of S multiplied with 3 by S. Already 1 by S is there, so you multiply with 3 here and you add. Finally, you will be getting Y3 of S. Okay, so now we got everything: H1 of S, H2 of S, H3 of S. Just we have to connect everything together. That's it. Okay. So final format: X of S 1 by S minus 0.5, then 4. This is Y1 of S. Okay, but Y1 of S is same as the X2 of S. Okay, now we are drawing the H2 of S. Then H2 of S is over. Next H3 of S. Again, this is the output of the second system, that is Y2 of S, but that is same as the input to the third system, X3 of S. Okay, finally, this is output Y of S. Okay, if we see here, this is the cascade form, and this part is H1 of S, this part is H2 of S, this part is H3 of S. Just we are connecting all together. Okay, so finally, we got the overall block diagram in the cascade form. Okay, so now the same thing will try to get, or we'll try to get with the help of the Mason's gain formula. Okay, again, you take this as exercise. Okay, for this block diagram, if you apply Mason's gain formula, definitely you will be getting the original transfer function, overall transfer function. Mason's gain formula. Okay, again you can see which are all the forward path, which are all the loop, whether they are touching or non-touching. So if you apply carefully, you will be getting the answer. Okay, then how to realize this H1 of S, H2 of S, H3 of S directly without using this method? Okay, because it is this transfer function is very simple format only, so that we can also directly realize it. We can directly realize it. Okay, instead of going through these steps. Okay, now we'll try that. Okay, before going to that realization, I will first write that transfer function. H1 of S is equal to 4 by S divided by 1 plus 0.5 divided by S. H2 of S is equal to 1 plus 1 by S, 1 plus 2 by S. H3 of S is equal to 1 plus 3 by S divided by 1 plus 4 by S. Okay, before going to this, we will just recap the control system formula. Okay, whenever the system is there with the negative feedback, okay, with the negative feedback of in this format, suppose if H is there here, again we will be writing G divided by 1 plus GH. Okay, if it is negative feedback. If it is positive feedback, G divided by 1 plus GH. Okay, but we need here negative feedback. Okay, so that we will be using coefficient as negative coefficient. Okay, we can either we can put minus here. If you put plus here, here I can use negative coefficient, no problem, all are same. Okay, so now we'll be using the negative feedback to realize this structure. And one more thing here is, say, this is like G divided by 1 plus GH. Okay, this is something like G divided by 1 plus GH. So I can take this 4 outside. Then G means 1 by S. Again, 0.5 divided by S. Okay, G divided by 1 plus GH, where G is equal to 1 by S. And what is the feedback gain? H is equal to 0.5. That is actually negative. Okay, negative value. Okay, because already we will be using adder, so that we will use the negative coefficient. Okay, so then how to get this? Okay, G divided by 1 plus GH. Okay, we can go like this. Okay, then 1 by S, 1 by S, then with a negative coefficient minus 0.5, then we can connect here. Okay, then we got H1 of S. Okay, this is X1 of S, this is Y1 of S. Okay, and also one more thing to note down here is we have just implemented this one. So again, we have to multiply with the 4. Okay, so finally, after getting Y of S, okay, after implementing this, I have to multiply here by 4. Okay, don't introduce this 4 inside. Okay, if you introduce again, everything will change. Okay, that's why I'm introducing this 4 after the function. Okay, once I got this function 1 by S divided by 1 plus 0.5 divided by S, later only I'm introducing 4. If you introduce inside, again inside you will be again inside the terms it will be changing. Okay, that's why please don't introduce this 4 inside. Okay, but again instead of this diagram you would have got in different way. Okay, but both are same. See, look at this diagram. After 1 by S you are taking the tapping, then you are multiplying with the 4. Again you can take tap just after 1 by S. Again you have to multiply with the 4. Same thing only we have already got. Okay, after 1 by S we are taking the tap, then we are multiplying by 4, and then another tapping is going as a feedback here. Okay, again this diagram and this diagram, it may look different, but it is exactly same. Okay, functionality wise exactly same. So instead of taking tapping here, I have taken here, no problem. See, this is in general in control system we used to take like this. Okay, otherwise if you are not comfortable, again you can also take here. Okay, no problem, all are same only. So just multiply with the 4, then you take y1 of s. Okay, then how to realize this function? Okay, it is having 1 plus 1 by s and also 1 plus 2 by s. Okay, again, if in the numerator, if you are having more terms, that means you are having more forward path. Okay, okay, in this case, you are having only one forward path, but in this case, you are having two forward path. There, one forward path is producing value 1, another forward path is producing value 1 by s. And also we know that here there is no non-touching loop, so that we will not get any extra term, because you might have studied like this: P1 del 1. P1 means forward path gain, and del 1 is the loop gain which is not touching the first forward path. Again P2 del 2. Again, if there is no non-touching loop, again del 1 will become like 1. So we'll just write P1 plus P2. Okay. So now we'll see how to realize. Yeah. Okay. So suppose just by trial and error I am going. Okay. I start with some x2 of s. Okay. In the same manner. Then I need the loop gain of 1 plus 2 by s. Suppose if I have 2 by s here, just I'm imagining. Okay. If I have 2 by s here, then I provide not 2 by s, that is, say for example 1 by s. Then again if I am using the minus 2 here, then it will go like this. Okay, then what will be the output of this one will be g divided by, that means 1 by s divided by 1 plus gs, that means 1 by s divided by 1 plus 2s. Then I have to introduce the one more term, I have to get this term. Okay, so now one way I am reaching the output from input through this way, that is 1 by s. Then what is the another way I will reach with the gain of 1? There is no other way, because you have introduced the integrator here. So I can try to go here, here like this, then I can reach here. But even though I am getting 1 by s, so that's why don't introduce the integrator here, you introduce here. Okay, so now I'm going to introduce this integrator here so that I will get the path gain of 1 here. Okay, so now I will just modify this. Okay, ultimately we have to realize this function, that's it. Okay, so x2 of s to come this way, you introduce integrator here. Okay, then what is the loop gain, that is minus 2. Okay, so now also you will be getting that correctly, that is 1 by s, 1 plus 2s, because loop gain is satisfied. Okay, loop gain is what, 2 by s, that is present here. Okay, then you go here, plus you provide one more path here, go this way, then put y2 of s here. Now you see, what is the forward path from here to here? Simply 1. What is the forward path? If you go this way, come this way. If you go this way, come this way, and then go and reach y2 of s. Again, here also forward path is 1 by s. Okay, for this one, forward path is 1. For this path, forward path is 1 by s. Okay, so the numerator is satisfied. Then in the denominator, we'll be getting 1 plus loop gain. How many loops are there? Only one loop. Okay, this is the only one loop we are having, because with this we cannot form the loop. Okay, because you are going this way, then again arrow mark is coming in the opposite way. So this is not a loop, only this is a loop. So we are getting 1 plus 2 by s. Okay, so in the similar manner, you can also draw the structure for this one. Again, it's very simply x3 of s, x3 of s going this way, then introduce the integrator here, introduce that coefficient here, that is minus 4, okay, summation, okay, x3 of s, so again add it here. Okay, this is path gain 1, again we need 3 here, so introduce that 3 here. Okay, you add, finally you will be getting y3 of s. Okay, just I am following this structure. Okay, here plus 2 is there, so that's why minus 2. Here plus 4 is there, so minus 4. Here 1 is there, that's why 1. Here 3 is there, that's why here 3. Okay, so like this also you can implement, but in the exam don't follow this method, because they might be expecting with this method, because this is already related with the direct form 2, so they may be having answers in this format. So that's why it's always better to solve these questions of cascade format with the help of the direct 2 format, instead of using this Mason's gain formula method. But anyway, you will be getting same structure, but it's better to follow that direct form 2 format for your cascade form realization. So system realization in parallel form. For a system H of s, X of s is the input, Y of s is the output. Suppose if there are 3 systems connected in parallel like this, H1 of s, H2 of s, and H3 of s. For all the system, the input is same, okay, same input x of s, but the output will be different because different system is having different transfer function. So the output is y1 of s, y2s, y3s. Then all the outputs are added together. Then we are getting final output, that is y of s is equal to y1 plus y2 plus y3. We know that y1 is x multiplied with h, y2 is x multiplied with h2, y3 is x multiplied with h3. Then x is common, we can take out, then h1 plus h2 plus h3. And also we know that overall y of s divided by x of s is same as the h of s, that is overall transfer function. So that the overall transfer function of the system is same as the addition of the transfer function. That means what? The entire system we can represent like this. Okay, entire system we can represent as a single system h of s. But in the exam, we will be given with h of s. Okay, now we have to split it in the different format. Okay, we have to write it in this format h of s. We have to write in this format. Okay, with the plus sign in between. Then we have to realize individually h1 separately, h2 separately, h3 separately. Then for all the h1, h2, h3, we'll be giving common input. Okay, but the output will be different. Then we have to add all the output. Then we'll be getting output y. Okay, that is the parallel form realization. Okay, now we'll take one example. Okay, we try to realize that using parallel format. Yes, realize the system using parallel form. The h of s is s and s plus 2 divided by s plus 1, s plus 3, s plus 4. We know that h of s has to be written like this. Okay, once if you want to represent in terms of parallel form, h1s plus h2s plus h3s. For that, we have to apply partial fraction technique. Okay, then if you apply partial fraction technique, ABC value is minus 1 by 6, minus 3 by 2, and then 8 by 3. Okay, this is h1s, h2s, and h3s. Okay, again, you take s outside, then that s we can take it in the numerator. Then we'll be getting 1 plus 1 by s. Similarly, for other two terms also. Now we'll be getting structure like this. Okay, now we have to realize this separately. Then finally, we have to add the output for all this. Again, the input for all the case is same. Okay, the input for all the terms are same, that is x of s, but output will be different. All the output has to be added together. Again, already we have seen this structure. Okay, in the numerator with 1 by s with some coefficient, in the denominator 1 plus 1 by s format. Okay, this format already we have seen, okay, in the previous problem itself. Okay, say in case of h of h1 s, we are having that format. Okay, 4 into 1 by s, again 1 plus 0.5 by s. Okay, so x1 of s is going this way, then w1 is the temporary variable. Okay, now we are using one integrator here. Again, this coefficient with the negative sign is utilized in the input side, that is minus 0.5. This coefficient, okay, that 1 by 4, sorry, 4, this 4 is used directly in the output side. Okay, so the coefficient present in the denominator we have to use in the input side with the negative sign. The coefficient present in the numerator we have to use it at the output side with the same sign. Again, the structure also will be in this format only, because all our h1 of s, h2 of s, h3 of s is of same format as of this one. Okay, so now we'll draw that. So x of s is coming, then we have to use integrator 1 by s. Please wait, I think the space may not be sufficient. Okay, x of s is coming this way. So now we have to use integrator here 1 by s. Then what is the coefficient present here that we have to use with the negative sign? The coefficient here is 1, that negative sign is minus 1. It is like a loop gain. Okay, loop gain. Now close this loop, then take the tapping from here, then use this coefficient. What is that coefficient? Minus 1 by 6. Okay, so now this is output y1 of s. Okay, this is output y1 of s. Okay, similarly, we have to find out what is y2 of s, what is y3 of s. Later, everything has to be added. Okay, now what about, again, this is x of s. Okay, this is input x of s. Then next one, this one, input x of s is coming. Again, use the integrator, multiply with the variable. What is that coefficient? 3, that means minus 3. Again, close the loop. Okay, then take the tapping from here. What is the coefficient here? Minus 3 by 2. use as it is minus 3 by 2, then this is y2 of s. Okay, similarly, you have to realize this also. Again, same x of s, add here, then use one integrator, close the loop with the coefficient of, I think here we have written wrongly, something is wrong here. We'll check. Okay, that is 4 by s, not s by 4. 4 by s. Okay, so what is the coefficient? That is 4. So use minus 4. Okay, then what is the coefficient here? 8 by 3 plus 8 by 3. Okay, this is y3 of s. Okay, so now we want to get overall output. Okay, so we use one adder here, combine this output with this output, and one more adder here, combine this output. Okay, finally we'll be getting y of s. Again, in this process, we are using same input. Okay, same input only. Input is same. Okay, same input y of s only we are using everywhere. That is x of s. X of s is same. Okay, for all the system, smaller system, but output will be different. But we have to add all the output to get the overall output. Okay, so now what you will do, you take it as an exercise. Try to get the overall transfer function for this with help of Mason's gain formula that is available in the control system, and also verify whether finally you are getting this. Again, you may not be getting like this. Again, you may be getting in a simplified format like s square here. It will start with s cube like that. Okay, and try to verify whether it is matching with our questions or not. And in this process, please remember, please check it out how many forward paths are there. Okay, this is one forward path, this is second forward path, this is third forward path. How many loops are there? This is one loop, this is another loop, this is another loop. Again, please check it out, any other loops are there or not. Mostly you will be having 3 loops. Again, whether they are touching or non-touching. Okay, again, non-touching. Okay, again, you write the loop gain individually. Again, 2 non-touching loop, 3 non-touching loop. Like that it will come. Again, when you write the numerator, P1 del 1, when you write the first forward path gain, again, what is the del 1? That means loop gain which is not touching the first forward path. Okay, you apply carefully. Okay, P1 del 1, P2 del 2 divided by overall del, then finally verify whether you are getting this or not. Okay, thank you.